So today we're going to work on a heuristic called make the numerators the same. Well, look at this here, this part of the Jenga tower. We've got two different pieces here, one long piece and three short pieces. And it kind of looks like they are of the same length, right? Okay, just bear with me here. Let's assume they are of the same length. We can form a statement that says one length is equal to 3 breadths. Well, the problem here is we've got two unknowns. Wouldn't it be simpler if we simply just cut up the longer piece to show, hey, these are actually 6 B's? Isn't that much nicer? So instead of two unknowns, we now have one unknown, B, 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 B. Well, this is kind of what we'll be doing for this question type. Suppose we are given two bars here, A is equal to B, equal length. And let's say you're told that 3 units of A is equal to 2 units of B. Now, this is not the best situation again because we have got two different units. We've got a smaller unit, we've got a larger unit. Now, with the information, with the fact being told to us that they are both of the same length, we can actually make our lives slightly easier by doing this. What just happened? Okay, I just converted these 3 units into 6 smaller units and the 2 bigger units here into 6 smaller units. And the good thing about this is I can just think of this as A having 6 units and B having 6 units as well. So we've got a total of 12 identical units. That is much nicer to work with compared to 2 different parts, which would be the 2 different kinds of units, which would be the smaller one up here and the bigger one down here. And we have turned it into 12 similar units. That's the advantage to this. And basically what just happened? We just turned 3 into 6 and 2 into 6. So what if we add fractions to the mix? Okay. Now, what I've done here is to show that 3/4 of A equals to 2/3 of B. Look, 3/4, this is the 4th unit here, but 3 of them is of exactly the same length as 2 units of B, which has a total of 3 parts here. So 2 out of 3 parts is exactly equal to 3 out of 4 units of A. Problem again is that we have 2 different kinds of units, a smaller one and a larger one. So what can we do? Exactly what we did just now. If we want to do a bit of drawing, it's going to be like this. You split such that this part here turns into 6 and this part here turns into 6 as well. Don't forget, we have to do the same splitting for the unit outside. But what have we just achieved? Based on our working and not just the model. Look, I've just made the numerators the same. And if I go back, look, this 3/4, I'm going to turn this into 6 times 2 times 2. Therefore, we get 6/8. Look at this 2 over here, the numerator. I'm going to times 3 and times 3. So that's 6/9, yeah? There you go, 6/9. And once I've done this, okay, the numerators are now the same, I can now look at the denominator and say A has a total of 8 units, B has a total of 9 units. And the goal for this, at the end of this video, is that you can do this instead of drawing models. Alright, so once you've done this, you can skip the whole thing up here, which is the drawing of the lines. So if I give you like 20 units, you do not have to worry and spend time drawing. So let's start with the first question, shall we? 3/4 of F is equal, and this, by the way, is how you recognize make the numerator the same questions. You will have a fraction of something equal to fraction of another thing. So 3/4 of F is equal to 2/5 of R. Find the ratio of R to F. So form an equation here, or in this case, I drew a model. So 3/4, which means total of F is 4. 3 of them are of exactly the same length as 2 of R. And make sure you show that R has a total of 5 units. Okay, so 3/4 F equals to 2/5 R. Now our focus is to make this part here the same, as we are told. They are currently different. 3 smaller units, 2 larger units. Make them the same. So how can you turn 3 and 2 to make them the same? Well, what you can basically do is to say, okay, these 3 guys, I'm going to make them 6. So 2, 2, 2, that's 6 units. Don't forget to put 2 here. So these 2, I'm going to turn them into 6 as well. So 3U, 3U, don't forget to do the same for the others. And now they are the same. Look at this, 6 units, exactly the same as 6 units. So this is for you because just to start out with, yeah. But working like that is much faster, much better, okay? So what we do is make the numerators the same. Look at this, 3 times 2 times 2, you get 6 over 8, times 3 times 3, you get 6 over 15. The numerators are now the same. And now we can conclude that F has a total of 8 units, R has a total of 15, looking at the denominators. So the required ratio is thus R to F, right? So R is to F is therefore 15 is to 8. That's it. Question 2. 7/12 of A is equal to 5/11 of Thomas's money. So again, fraction of A equal to fraction of T. This is how you identify the question type, yeah? So without drawing the model, let's do it, okay, in the fast way. So 7/12 equal to 5/11t. Now make the numerators the same. So I'm going to just multiply by 5, multiply by 7. We will obtain 35 over 60, 35 over 77. Now that the numerators are the same, they want the ratio of A, which happens to be the denominator here, 60 units, as a ratio of the total, the children's total. Now, that's not T, is it? That's not 77, is it? It's the sum of 60 and 77. So the final ratio is thus 60, which is A, and 137, which is A plus T. 2/3 J is equal to 3/4 S. So we can form the statement 2/3 J equals to 3/4 S. And let's make the numerators the same, times 3 times 3 times 2 times 2. Next up, we'll have 6 over 9, 6 over 8, which means we can conclude J has 9 units, S has 8 units, and they want J to S, so quite simple, 9 is to 8 is the answer. 5/13 of G equal to 8/15 of B. So this shall be our first step. Now look at the numerators 5 and 8. We can turn them both into 40, like so. And then we are going to look at the question requirement. Boys to total children. Okay, so boys is 75, as seen here. Total children is 104 plus 75. So that leaves us with 75 is to 179. 1/3 of L is equal to 5/6 of A. Alright, so first statement is 1/3 L, 5/6 A. Now, here we can just turn 1 into 5. That means we don't have to do anything over here. So times 5 times 5, we will get 5 over 15L equals to 5 over 6A. At this point, conclude that L has 15 units, A has 6 units. Now we are told Laura has $36 more than A. So the difference, L, $36 more than A, which means the 9 units difference represents the 36 actual dollars. So 1 unit is therefore $4. How much do both girls have together? So I'm curious about how many units? 21 units, isn't it? So 15U plus 6U, that's 21 units. So if 1U is $4, 21 units therefore is 21 times 4, giving us $84 for the answer. At a sports carnival, 2/3 of boys equal to 3/5 of girls. So right off the bat, we can form this step here. And as usual, we're going to make the numerators the same. And this brings us to boys being 9 units in total, G being 10 units in total. So let's make everything clear. B is to G is 9 is to 10. Now there are 50 more girls than boys, so that 1 unit difference is going to be representing 50 actual children. How many pupils? So basically we are looking for a total of 9 units and 10 units. That's 19 units. And since 1U is 50, we're going to take 19 times 50, giving us 950 for the answer. Agnes and Mandy collect stickers. 3/5 of A equal to 2/5 of M. So 3/5 A equals to 2/5 M. So numerators 3 and 2, let's turn them both into 6. At this point, we know A has 10 units, M has 15 units. If we are told Agnes has 30 actual stickers, that means 10 units represent 30, 1 unit represents 3. How many stickers altogether? Which means we are interested in the 25 units, are we not? 10U plus 15U, that's 25U. So if 1U is 3, 25U must be 75. There are 36 members in the judo class. 7/8 of the men equal to 7/10 of the women. Whoa, how nice of this question to actually make the numerators the same for us already. So we can immediately conclude there are 8 units for men and women 10 units. Simplify, you don't have to, but it's easier to work with the smaller numbers. Turn it into 4:5. Now there are 36 members if you recall, which means the total of 9 units represent 36. So 1 unit is therefore 36 divided by 9, 4. Now how many more women than men? Do you notice the difference happens to be 1 unit? So that is our final answer. 1 unit here, the difference is 4. 7/15 of C equal to 3/10 of D. So let's form the statement here. 7/15C equals to 3/10 of D. Make the numerators the same. In this case, turn them both to 21. So conclude now that C has 45 units and D has 70 units. Both are multiples of 7. So let's divide that by, let's divide by 5. Okay, sorry, not 7, 5. Okay, $460 all together. So let's sum the numbers up, the units up. That's 23 units representing 460. Okay, so 1 unit is therefore 20. What does the question want? What's the difference between D and C? So let's take the difference in units. Okay, so that will be 5 units difference. So if 1 U is 20, 5 units is therefore $100 in terms of the difference. 1/4 K is equal to 2/5 of D. The difference in the amount of money they had is 171. So let's form the equation. 1/4 K equals to 2/5 of D. Make the numerators the same. Now make sure you know that K has 8 units and D has 5 units. And we are told the difference, which is 3 units, is 171. So we can form an equation with that. 3 units, 171. 1 unit, 57. What is the total that they both had? So we want to sum the units up. That's 13 units. And 1U 57, 13U means $741. 407 of A is equal to 508 of T. So let's form the equation here. 407A, 508T. Turn that both into 20. Numerators the same. And therefore conclude that A has 35 units. T has 32 units. We are told now that the total is 335. So the sum is 67 units, representing the 335. 1 unit is 5. How many more did A have than T? So the difference is between them is 3 units. So 3 units, 1 unit is 5, 3 units is 15. 2/7 of girls equal to 3/5 of boys. So 2/7 girls, 3/5 boys equal, make the numerators the same. So now we've got G having 21 units and B having 10 units. What fraction of the number of children were girls? So children, total, okay, girls over total. So girls is 21, total is 31. So this is the required fraction right there. Part B, there were 253 more girls than boys. So the difference between them is 11 units. And that represents 253. How many girls were there? So we want to find out what 21 units represent. So you can divide by 11, which is 1 unit, and then multiply by 21, giving us 483. 1/3 L equal to 56A. So 1/3 L, 56A, make the numerators the same. Conclude that L, 15 units, A, 6 units. The difference between them is $36. So $36, 9 units is 36, 1 U is 4. How much money do they have altogether? So that's 21 units. So we're looking for 21 times 4, that's $84. And now we're going to do level 2 questions. 1/4 A equal to 3/8 of B. Alright, so let's form this part here. 1/4 A, 3/8 B. Make the numerators the same. A has 12, B has 8. What fraction of A must be given to B so that they both have the same? Well, if they're going to be transferring internally, then the total remains unchanged, right? Currently, the total is 20 units. After they just changed money between them, the total should be the same. So what that means is, if you take this divide by 2, because they both had the equal amount in the end, they both should have 10 units, right? 10 and 10. So how many units did Aisha give? 2 units. And this is what fraction of her total at first? It is 2 units out of the total of 12 that she had at first. So it was 1/6 of what she had to be transferred to Ben. 3/7 of A equal to 16% of K. Okay, we are used to having a fraction of something equal to fraction of another thing, right? Don't forget, 16% can be written as a fraction as well. It's 16 over 100. If you simplify it, it's 4 over 25. And at this point, let's make the numerators the same. 3 and 4, let's turn them both to 12, shall we? So times 4 times 4, times 3 times 3. So A has 28 units, K has 75 units. So if the difference between them is $188, so the difference is 47 units, representing 188. 1 unit is 4. How much did Anthony have? Anthony has 28 units. So we shall find 28 units, therefore, multiply by 4, you get $112. 3 bakeries, total 380 cupcakes at first. Bakery A sold half. Okay, so Bakery A had half left, yeah? So 2/3 for B, which means 1/3 left. Okay, by the way, they sold the same number. So that means half A sold is exactly the same as 2/3 B is exactly the same as 4/5 C, because they all sold the same number. So now we've got 3 fractions being equal. Half A equals to 2/3 B equals to 4/5 C. Now let's make the numerators the same. The rules don't change. It's still the same. So let's keep the 4 and turn this 1 into 4 and turn this 2 into 4. So times 4 times 4 times 2 times 2. Now the numerators are all the same. What can we conclude? A has 8 units, B has 6 units, C has 5 units. Okay, remember the total was 380? What that means is we can find out 19 units equals 380. 1 unit is 20. How many did each bakery sell? Alright, so 4 units is therefore equal to 80. Why? Because each bakery sold 4 units, didn't they? Right here. So each bakery sold 80. 3 family members shared the cost of buying a flat equally. Adam used half, so half of A spent. They shared the cost equally, right? So half A equals to 6/7 B equals to 3/4 C. So that is what we're going to write exactly. So make the numerators the same, turn them all into 6, which means A spending is 12 units, B spends 7, C spends 8 units. Now we are told that B and C had 44820 left after paying for the flat. Alright, so what that means is, look, if B spent 6/7 of his money, how many units does B have left? 1 unit, right? If C spends 6/8 of his money, how many units left? It's 2 units. So we can conclude that the 3 units represent in total 44820. 1 unit is 14,940. So it's a bit challenging here. Yeah, notice this is what they had left. So spent 6/7 units, had 1 unit left. Spent 6/8 units, had 2 units left. So 1 unit is 14,940. How much did the flat cost? In other words, how much did they spend? They spent an equal amount, 6 units, 6 units, 6 units, right? So they in total spent 6 times 3, 18 units to buy the flat. So if 1 unit costs this, 18 units costs $268,920. Mr. Tan had this number of apples and pears, 1/4 of A equal to 2/3 of P. Okay, that's a useful statement there. Let's make the numerators the same. So times 2 times 2. So A, 8 apples, 8 units. Okay, pears, 3 units. Since the total was 495, we can find exactly how many apples and pears. So 8 units is therefore 360, representing apples. So with this number of apples, they were packed into packets of 3. So the number of packets is just how many 3s in 360? That's 120 packets. And each one was sold for $1 each. I just repeated myself. So each is sold for $1. So how much would he receive? $120. Now, so far you are used to questions telling you that half of A equals to 3/4 of B, right? They tell you directly, fraction of A equals to fraction of B. Sure. Now, but for these questions, it will be told to you indirectly. So it requires guessing, it requires inference. Okay, so let's see what that's all about. L and S each had the same sum of money. Okay, S spends 3/5, L spends 3/7. Two of them same amount left. Oh my goodness, what does that mean? If 3/5 of S was spent, that also means 2/5 of S left behind, remaining. If L spent 3/7, L had 4/7 left. Now we are told that they had the same amount left. Isn't that indirectly telling you that these two fractions are the same? And this is what I mean by requiring inference. You need to guess that these two fractions are the same. So there you go. Make the numerators the same, nothing different here. From here, conclude that S has a total of 10 units, L has a total of 7. What fraction of the total sum of money is Shane's money? Oh, Shane's money is 10 units, isn't it? And the total, is it not 10 plus 7? So it's 10 over 17. That's the answer. Mrs. Lim bought some almonds and pistachios. She used an equal amount of them. She had 1/3 L, 1/3 A, and 4/7 P left. Okay, so she used the same amount. Alright, so if 1/3 of A left, she used 2/3 of A. If she had 4/7 of P left, she used up 3/7 of P. And we are just told that she used the same amount of A and P. That is indirectly telling us that 2/3 A is equal to 3/7 P. So make the numerators the same at this point. A has a total of 9 units, P has a total of 14 units. What ratio of the nuts used by Mrs. Lim to the nuts that were left? Okay, so what's the number of units used? Okay, is it not 6 units used? 6 units P used? It's the same amount used, right? And it's 6 and 6. So that's 12 units used. And the total that's left, well, if it's going to be 6 units and 6 units used, the total will just minus 12 and you get the remainder. That's one way of finding it. So I say again, the total is 9 plus 14, yeah? 23 units. If 12 units were used, then 11 units were left. So the ratio, therefore, if you read carefully, is the number used is to the number left. So this is the ratio. So SY gave away 2/5, SM 8 1/7, both same number left. Okay, so 2/5 of SY given, 3/5 of SY left. 1/7 of SM eaten, 6/7 of SM left. And because these two fractions left, we are told, the same number, we can form an equation like so. Make the numerators the same. Conclude that SY to SM is 10 units is to 7. What fraction of the total, which means 17, right, did SM bake? Well, SM baked 7 in total. So that's 7 over 17. 285 children took part in the competition. 2/5 boys, 1/3 girls were prize winners. Okay, so if 2/5 boys won a prize, 3/5 of the boys had no prizes. 1/3 of the girls won, 2/3 of the girls had no prizes. An equal number of B and G did not win any prizes. So these two fractions are the same. So let's form that equation. And here we go. And make the numerators the same. We can conclude that a total of 10 units for boys and 9 units of girls. How many children were prize winners? Okay, so if we are told that the total was 285, then the total of 19 units here represent 285. 1 U is therefore 15. So how many children were prize winners? So notice that we've got 6 units of boys not winning anything, 6 units of girls not winning anything. So the total non-prize winners is actually 12 units. So the total units is 19, non-prize winners 12, prize winners must be 7 units. So how many were prize winners? 1 unit is 15, 7 units is 105. 2/3 of the pupils here and 3/8 of the pupils in this primary school are girls. Okay, both of them have the same number of boys. Okay, so we can conclude that if 2/3 of Sunshine are girls, 1/3 of Sunshine are boys, 3/8 of Orchid are girls, 5/8 of Orchid are boys. Both primary schools have the same number of boys. So we can say that 1/3 S equals to 5/8. Make the numerators the same and conclude that Sunshine Primary has a total of 15 units, including boys and girls. Orchid Primary has a total of 8 units of students. So there are 840 more pupils. So the difference here is going to be 15U minus 8U. That's representing 840. So 1U is 120. How many pupils are there in Sunshine, which means we're looking for 15 units. Therefore, 1800 is the answer. Stella saved $84 less than Jenny. Okay, nothing to do here. After S donated 2/5 to charity, Jenny spent 2/3 of the money. They had the same amount of money left. Okay, so if 2/3 of S was donated, she had 3/5 left. 2/3 of J spent, 1/3 of J left. And we are told they had the same amount of money left. With this, we can conclude that this is true. Make the numerators the same. S total 5 units, J total 9 units. And if you recall from the first sentence that the difference was $84. So therefore, 9 minus 5, that's $84. 4 units is 84, 1 unit is $21. How much money did J have at first? J at first is actually 9 units. Okay, so 1U is 21, 9 times 21, $189. ABC share some money, 1/4 of A equal to 1/2 of B. Okay, that's nice. So 1/8 A equals to 1/2 of B. So the numerators are already the same. We can conclude that A has 4 units, B has 2 units. Ben gets 1/3 of what C gets. Oh, that means C has 3 times of B. So whatever B is, multiply by 3. So C actually has 6 units. Now we are told that Ben gets $50. So 2 units therefore represent $50. 1 unit, 25. What's that total sum? So it's 4U plus 2U plus 6U. That's 12 units. And therefore, we're interested in 12 times 25. That's $300. There were 55 children in the room. 2/3 of the girls, 1/2 of the boys wore spectacles. An equal number did not wear spectacles. So let's form the statement again. 2/3 girls with specs, 1/3 girls without specs. Half boys with specs, half boys without specs. Total students without specs was the same. Boys and girls, equal number, right? So therefore, 1/3 G is equal to 1/2 B. The numerators are already the same. So boys and girls, 3U and 2U. Recall that the total is 55. So 1U is therefore 11 children. How many girls did not wear spectacles? So if you're talking about girls without spectacles, it's 1/3 of the girls, isn't it? 1/3 of the girls didn't wear spectacles. So one way to find out is how many total girls were there? 33, right? 11 times 3. And then you take 1/3 of that. Or you can just take 1/3 of the total units, which is 3 units. 1/3 of total 3U is 1U. And voila, 1U is actually 11. We just found out. And now we have got percentage. So fraction of something equal to fraction of another thing. So just write 32% as a fraction for a start. So 32% equals to 3/4 of O. Turn this into 32/100. Simplify. Now turn the numerator both to 24. Make the numerators the same. Conclude that J had 75U and O had 32 units. If they have a total sum of this number, okay, form an equation. 1U is 6. How much does Omar have, which is 32 units? That's $192. JKS used the same number to make necklaces. J used 3/4 of her beads. K used 2/3. Sally used 1/2. They had a total of 290 beads at first. Hang on, they used the same number. So use this, use this, use these. These 3 fractions are exactly the same. So that means 3/4 J used, 1/4 J left. 2/3 K used, 1/3 K left. Half S used, half S left. Same number used for all. Therefore, all of these 3 fractions are the same. Make the numerators the same, turn them all into 6. And conclude that J, 8 units in total. K, 9 units in total. S, 12 units in total. Alright, we are told that the total is 290, so we can form an equation. 1U is 10. Alright, so how many beads did each girl use? They all used the same number, yeah? So they used 6 units, didn't they? So I just realized that I went the long way round. Okay, so if all of them use 6 units, I could have just found 6 units equals 60 straight away. Okay. Instead, if you look at this, I went to find the number of J's beads, which is 8 units in total, and then she used 3/4 of her beads. Yeah. So 3/4 of her 80 is 60, and since all of them use the same number, each girl used 60. I could have just found 6 units, and that would have been a shortcut. 3/5 of x is glued to 2/5 of y as shown. Now, for some reason, I used a and b, so take this as x, take this as y. Okay, apologies for that. Now, 3/5 of x glued to 2/5 of y. Okay, what do you notice here? It's trying to tell you something indirectly. What is it? It is that 3/5 of x is glued to 2/5 of y, which means these two are of the same length. They are both occupying the same length. Now, that's basically telling you to make the numerators the same. 3/5 x equal in length to 2/5 y, make the numerators the same, conclude that x has a total length of 10 units, y has a total of 15 units. What's the ratio of x to y? Hey, it is 10 to 15, simplified, 2:3. There were some men and women on a bus. 10 women alighted from the bus. Okay. As a result, the percentage of men increased from 30% to 45%. All right, so if I'm going to draw a model, it's going to look like this. Yeah. Now, the result went from 30% to 45%. Now, however, the total is completely different. So B here stands for before. So before that, 30% of the men were 30% of the total before was men, which means automatically that before that, 70% were women. So there are 10 women left. The total is now different. That's why I'm calling it before and after. All right. We are now told that it's 45% of that new total were men. So if 45% of the new total were men, 55% of that new total was women. Because men unchanged, no men left or boarded the bus, these two fractions should be the same. In other words, 30% of the number before must be the same as 45% of the number after. So what's 30% as a fraction? That's 3/10. 45%, simplified, 9/20. Make the numerators the same. Now we can conclude that the total men and women before, 30 units, the total men and women after, okay, was 20 units. So how many women were there at first? That's 70% of 30 units. That's 21 units. How many women were there after that? 55% of the total after. That's 11 units. So if 10 women left the bus, then we've got 21 minus 11. That's 10 units representing 10 women. How many people on the bus at first? We're interested in 30 units. Okay, so we are going to find out what's 10 times 3? That's 30 men and women on the bus at first. And now level 3 questions. Joy spent 3/4 of her money on 3 blouses. Okay. Grace spent 4/9 of her money on 2 skirts. They were each left with an equal amount of money. All right, so this tells me if J spent 3/4, she had 1/4 left. If G spent 4/9, she had 5/9 left. And if we are told that this amount is the same, we can form an equation saying 1/4 J is equal to 5/9 of G. Make the numerators the same. J had a total of 20 units at first, 9 units for G at first. Next, if 3/4 of J was spent on 3 blouses, right here, 3/4 of J. So what's 3/4 of J? That's actually 15 units. And 15 units was spent on 3 blouses. All right. So 1 blouse, you're going to divide by 3, right? So 1 blouse actually costs 5 units of money. If Grace spends 4/9 of her money, Grace spends 4/9 of her money on 2 skirts. So Grace spends 4/9 of her money on 2 skirts. That's 4/9 of 9 units on 2 skirts. That's 4 units on 2 skirts. If you divide by 2, that's 1 skirt costing 2 units. Okay, the blouse costs $9 more. Recall, 1 blouse, 5 units, 1 skirt, 2 units. So the difference must be 3 units. And that's $9, the difference. How much money did they have altogether at first? If 3 units is 9, we're interested in money altogether, that's 29 units, is it not? So we're going to find 29 units, therefore it is $87. 3/4 of C's allowance monthly is equal to 6/7 of L's monthly allowance. Alright, so this is something we can work with straight away. So let's have it. 3/4 of C equals to 6/7 of L, which means C, make the numerators the same. C has total of 8 units, L total of 7 units. What fraction of C's allowance is L's allowance? Okay, look at this word of here. What I usually do is look at the name right after that. I know that's my denominator. Okay, so C, 8 units, that's the denominator right there. And L, 7 units, is the numerator. Don't make the mistake of thinking it's always the larger number that has to be below. No, okay, it depends on what the question is asking for. Anyway, moving on. Both C and L spend the same amount each month. Okay, so at the end, Kara, 4 times of L. Alright, so the concept that you should know at this point is that if C had 8 units, let's pretend this is C, right, longer bar, L 7 units, if they spent the same amount of money, I hope it's clear that the difference is the same. So pretend there was no spending, the difference would be this part here, right? Now that they both spent the same, the difference is still this part here. The difference remains unchanged. Okay, so what we have is actually quite useful. If C has 8 and L has 7, the difference is 1. But after spending this mysterious amount of money, and these two are the same by the way, the ratio became 4:1, which means the difference is 3. So if the difference is unchanged, why should it be 1U and 3U? It should be the same. So here, this is where we're going to make the difference the same. We're going to multiply this by 3, by 3, by 3. So instead of saying C has 8 units, now C, take it as 24 units, L 21 units. Now this makes sense. Starting out with these two, the difference was 3. After C spent some money and L spent some money, this became 4:1 as told to us by the question. The difference is 3 still. Okay, now what can we conclude from here? If they spent $400 in total a month, okay, what does that mean? Look, what is 24 minus 4? That's 20 units, isn't it? Okay, so 20 units, what's 2 of them? Remember, this is C spending, yeah? 20 units. See, 24 to 4, that's spending 20 units. Now recall that they both spend the same amount each month, right? So the spending in total is 40 units. And we are just told that that's $400. So 40 units is $400, 1 unit is therefore $10. How much is Kara's monthly allowance? Therefore, what's 24 units? That's going to be $240. So the key concept here is, there are 2 concepts here. Numerators the same as well as difference the same. V, J, and Z share the cost of a present. What that means is that fraction spent must be the same. 3/5 of Z equal to 1/3 of J, total of J and V. Oh my goodness, this is what makes this a level 3. So the first statement I'm going to form is slightly different than what we are used to. 3/5 of Z is equal to 1/3 of 2 people's share, yeah? 1/3 of J and V. Now, we can still make the numerators the same. That means Z, 5 units. J and V, 9 units. So the total is 14 units. Okay, keep this. Don't look at this at the moment. Just look at this. Okay, so total is 14 units for the 3 people. Yeah. Next sentence. 2/3 of J is equal to 1/3 of total Z and V. Okay, 2/3 of J equals to 1/3 of total Z and V. Now, make the numerators the same. Conclude that J has 3 units. Z and V together, 6 units. Total 9 units. Now, we can simplify this. Everything here is multiples of 3, so divide by 3. Hang on. Why should the total be 14 and 3? Remember, we are talking about the total being ZJV, ZJV. So why should the total be 14 and 3? They should be the same, shouldn't they? Right? So let's turn 14 and 3 both into 42. Therefore, we're going to multiply by 3. And we're going to multiply by 14. Now, what we can do at this point is now the total is the same, which means we can use Z equals to 15 units. Okay, we can conclude Z is 15. J alone is 14. And what is V? We can find V by taking whichever number. Let's say J and V 27, right? So we already know that J is 14. So 27 minus 14 is 13. So now we know the exact number of units for all three people here. Okay, Valerie 30 less than Z. Okay, so V 13 less than Z. So the difference is 2U and that's 30. How much did the present cost? Okay, the total spending to buy the present is 42 units. Therefore, 2U is 30, 42. Well, I just did something funky here. You can find 1 unit and find 42 units, no problem. But what's 2 to 42? Isn't it multiplied by 21? So I'm taking 30 times 21. So it's $630. Mrs. Tan had some chocolate vanilla muffins at first. She gave away 2/5 of the C's and 5/7 of the V's. She gave away exactly half of the muffins altogether. Wait a minute. If half of the total were given away, doesn't that mean half of the total was left? Which means what's given away is exactly the same as what's left. Okay, so 2/5 of C given, 3/5 of C left. 5/7 of V given, 2/7 of V left. Okay, doesn't that mean that the total given away, which is 2/5 C and 5/7 V, is exactly the same as the total left, which is 3/5 C and 2/7 V? Right, total given away exactly the same as total left. Oh, we can work with this. Okay, let's look at the V's here. Look at this 5/7V, stays here. Look at this 2/7V, bring it to the left side, it becomes negative 2/7V. 3/5 C stays here on the right side. Now look at this positive 2/5 C, bring it over to the right side, becomes negative. And look what we have here. 5/7 V minus that, that's 3/7 of V. Subtract, that's 1/5 of C. Does this not look familiar? Numerator is the same. Let's multiply by 3 and 3. So we can now conclude V has a total of 7 units and C has a total of 15 units. All right. So in the end, she was left with 14 more chocolates than vanilla. Hang on. Let's look at the muffins that were left, shall we? So in terms of V left, isn't that 2/7? 2/7 of V. Okay, what's 2/7 of V? 2/7 of 7 units. That's 2 units left. What's C left? 3/5 of C left. Okay, what's 3/5 of 15 units? 3/5 of 15 units. That's 9 units. And we are now told that the difference is 14 actual muffins. So that means 9U minus 2U is 14, 7U is 14, 1U is 2. How many chocolate muffins did she bake at first? So we are interested in 15 units then. Total chocolates that were baked at first. So if 1U is 2, 2 times 15, that's 30. 2/5 of G equal to 7/9 of H. Alright, we can work with that instantly. 2/5 of G, 7/9 of H, make the numerators the same. We can conclude that G had 35U at first, H had 18 units at first. Alright, next. H received another 56 from the brother. So, before that, G gave 2/7 to H. Well, let's find out exactly how many units that is. What's 2/7 of G? That's 2/7 of the 35U weight that we have just found, right? So 2/7 of G given to H. So what's that? That's actually 10 units. So we're going to transfer 10 units from G to H. This means G has now gone from 35 minus 10 to 25. Add 10 units here, that's 28 units. All right. And let's show that H received another 56 actual stamps from her brother. Not from Gerald, from her brother. So not from here, yeah? Extra 56. So instead of writing 28U, I'm now going to write 28 is to 56. In the end, Gerald had 5/12 of the total that they had. Hang on. If 12 units is the total, doesn't that mean Gerald had 5? And if 12 is the total after that, 12 parts, then H must have had 7 parts. Okay, so if G had 5/12 of the total, that means G to H must be 5:7 as seen here. Now what does that mean? So if this is equal to 5 parts and this is equal to 7 parts, what happens if I multiply this by 7? That's 35 parts, right? What happens if I multiply this by 5? That's 35 parts as well. So you know what I can do? I can multiply this by 7. It will be exactly the same as this multiplied by 5. So that's exactly what I'll do. 7 times 25u plus 5 times the entire 28u plus 56. Which means this must be multiplied by 5. This must be multiplied by 5 as well. So let's do that. Form an equation that is going to be 175u equal to 140u plus 280. Okay, move this to the right hand side. Going to have 35u. And we can find 28 units, which is 224. Yeah. So why 224? How many stems did Hui Ling have in the end? Notice Hui Ling in the end is 28u plus 56. So I am interested in 28u, so that's why I found this. So what's h after? Is 28u plus that 56, which means 224 plus 56, that is 280. And that's it. The level 3 questions are done. Hope you found this useful. This is, again, numerators the same. And have a great day.